arrangement. Yes, it's a arrangement of a different rock formations according to their formation on surface of Earth. So here we see the chronological sequence. The chronological sequence, it belongs to the different rock formations and which are established in the terms of the relation of a different age. That means it's speaking about the age. It's known about the age of a different rock formations. So we know when you go into in your vertical section of these rocks, the older rocks will be found below the younger formations. And these rocks are deposited, it's a lateral lie over once a deposit or once the deposit of rock formations are formed at area. So that generally we can say the younger formations which are formed or which are preserved, an advanced form of organisms. So that we see the age of a different rock formations and different organisms also we will get when you see in a vertical section of the same formations. And those organisms we can see as a fossils. We get in the form of fossils and different relative ages of a formation of a rocks. So that sometimes maybe we completely the rock formations we may find out the fossiliferous rock formations. If we know the maximum of rocks which are formed in a group of formations, and those will be deposited more than 500 million years, which are generally devoid of any fossil records. For determining the relative age of fossiliferous as well as unfossiliferous rocks, we'll use some principles. Those principles are known as principles of stratigraphy. And along with that one, we see the order of a superposition. The order of a superposition, every geological formation, it's a rests, which are formed on another. And again, it's superimposed by another formation. We know that commonly the bottom formation always it is old. Naturally, we can say that it's as a old, and the younger one it is formed on the top. Here, each overlying bed is younger than underlying bed. That's a normal underlying bed means here it's a older formation which are formed in the normal conditions of a stratification, and the order it is known as a law of a superposition, or it is called as a order of a superposition. Yes, based on this principle, we can determine the relative ages of a different rock types like sedimentary formations, or sometimes we may get the volcanic structure formations. And if we collect that the same sample from those one, and we have a chance to determine the different ages. And again, the rock formations, how they were formed from bottom to top. We collect this sample as a representative from each area, and we'll determine the ages with using of these sample formations. And again, along with it, this property, and we have a chance to study the lithological characters. The study of a lithological character is known as the lithological formations and lithological characteristics. It helps to divide the rock sequences in each formation of a rock. Each lithological unit is consisting of a number of individual beds. Number of individual beds which are having the more or less same characters, and we are calling that is as a formation of a different age or belonging to the another area. That means depend on their formations and depend on their lithological characteristics, we can say whether the formation belongs to the which area. Suppose if you can see the Barakar sandstone, Kampi sandstone, Kumbum slate, Bempalli limestones, and etc. and etc. And we do the study correlation of among these rocks. Then we can say based on that results, yes, this formation belongs to this area, and this formation belongs to this area. Depending on the correlation studies, we can have a chance to say. The correlation is done by the tracking of the two distinct characteristics of different bed formations. Those beds are called as a marker beds. The rock formations that occurs between the two marker beds, it's a neighboring areas which are considered to be as a formation of two marker beds. Suppose if you see that's the Barakan sandstone of a lower Gondwana formation, it's mainly exposed, it means it's exposed in Jeria coal fields, and little bit of it's consisting of weathered feldspars, and again along with some feldspar bearing sandstone grades. Occasionally we see the association of the conglomerates and shales also. The same type of rock formations. Suppose if you see the same in a Raniganj or a Darjeeling, Assam, and other areas, and it's also considered as a same age. It is called as a same Barakar sandstones only. So the rock formations of the same age, but maybe it is deposited in different areas or different sedimentary basins in different areas, and then the lithological characters are most of it's same. Yeah. Next one, it is structures and the tectonics. The sediment deposit we see in a various sedimentary basins and which are flow uplifted above the surface. Then what is happening? If it is above the uplifted above the surface of a different water at different times, it will be raised to the edge, and those moments it's having some moments, and such moments are called as a tectonic moments. And it's deforming there is to formation of different structures in a rock, and it has a chance to creation of a gap. Then between that the gap it's formed by the deposition, and the gap it is called as a, or the period it is called as a non-deposition period or non-deposition. Suppose if it is a deposited later with the sediments in the basin which are not conformable, maybe it's a earlier, the sediments are developed in earlier stages. Then the surface it's a separating in a two successions, so that the gap it is formed. The gap it is called as a unconformity. The gap it is called as a unconformity. In this unconformity, it doesn't have any minerals or any deposition, mineral deposition. And again, a sequence of rock formations in a particular area, it can be divided into the major rock groups and separated from one another by a such surface of unconformity. The field and unconformity it's commonly evidenced by the presence of a conglomerate. So that if there is no visible and a break and the formation of a show, it's a complete parallelism in the strength of a gap in a sedimentation. It is called as a disconformity. The formations which are lying between the two successive surfaces of unconformity in a neighboring areas and which are considered as a same age. And again, the tectonic moments are also recorded within a single group of a rock succession in the form of rhythmicity of a different lithological types. The basin of a deposition may undergo successive phases of a deepening or a shallowing, which are reflected from the deposition of sediments. Alternatively, in the basin, the presence of a sandstone, it's indicating the shallow of a water deposition, and that of a shale, it's a sea water deposition. And again, we see the fossil records also, how they will form the fossil. Yeah, the organic remains which are preserved in a rocks, and it has been most widely used for determining the relative age of a rock formation and deposited during the last 570 million years. Yes, this type of organic remains which are preserved in a rock, and it is indicating the kind of life it's existed on the earth. That means it's indicating they were lived at the formation of the same earth. So that it's indicating the same age, and so that it is indicating the same age of the rock also. Yeah, such fossil records are more reliable to determine the relative age of rock formations, and we have a chance to correlate it of large areas. Yes, this method it is based on the faunal and the floral assemblages of formations, and it's never repeated again and again in a geological time, and the organisms and continuously they will form, and it's indicating the changes of morphological features of that area. Yeah, each assemblage of past life, it's a preserved in a rock, and it reflects the specific stage of the evaluation. And generally, the index fossil assemblages and reflects assemblages, and it is showing the microorganisms which are used to main tools for determining the relative ages of different beds in a different rock sections. What is the index fossil? Yes, some in extinct organisms have wide geographical distribution, and those are restricted to particular geological age only. Such type of extinct organisms are known as index fossils. Generally, index fossils have a distinct morphological features by which they can easily identify. Just example for graptolites, those are dominantly distributed in the Ordovician period, in the Ordovician period of sedimentary formation, and they were completely extinct in the rocks of a Silurian period. And second one, it is a trilobites. The trilobites are maximum dominant during the Cambrian period, and the particular Voronellus lived in lower Cambrian, and Paradoxite lived in the middle Cambrian period, and Voronus lived in upper Cambrian. These are all the best examples. Use of these fossil index. What's the use of these fossil index? The fossil index it's useful for the study of a fossil stratigraphic classification, and also it's useful for to study the correlation, and it's considered as one of the quickest methods. And index fossils have wide geographical distribution within the short interval geological time, ignoring the limitation of the conditions of a habitat. In the view of a limitation index fossils, the total fossil assemblages of the bed is examined and compared with those of other beds. What about the fossil assemblage? The total number of fossils preserved in the rocks will be taken into the account regarding the relative ages of rock formations. One group of a fossil can be cross-checked with another group. That means here, the group of the fossils or number of fossils are preserved in the rock. That means, again, it's a group was created. Mass or a number of fossils were formed in the same rock formation. So such type of assemblage, it is called as a fossil assemblage. Not only in that one, in the microorganisms, the fossils we can see as the microorganisms like a foraminifera, radiolaria, astrocodes, diatoms, pollens, spores, which are extensively used for determining the relative of rock formations. And sometimes maybe we need to get a particular area of material. So then we can choose the sedimentation of the area and we go into the deep drilling core samples. In your core samples, based on the core samples, we have a chance to study these above mentioned foraminifera, radiolaria, and astrocodes and diatoms. These are all we can study with small particles like pollens and spores. We can be able to identify very easily with that one. And some geophysical methods also will be useful to find out the subsurface of rock formations of the earth. And it's involved the field measurement to certain properties like gravity, magnetism, seismicity, and electricity, and electroresistivity, drops of a different sensitivity of instruments. Based on these instruments, we can be able to identify the different mineral deposits which are having in the sedimentary formations. Yeah, correlation. Correlates a very important aspect in a stratigraphy point of view. Its main aim is to matching the rock formations of different areas which are deposited in the same stage of the Earth evolutionary history. Such two formations are deposited at the same time or referred as a homotaxial. The word it's a very important homotaxial. It's indicating the two formations deposited at the same time. Two formations were deposited at the same time, that is called as a homotaxial. If two formations are not formed at the same time, and it is indicating they may not synchronous in their origin. A standard geographical scale or a standard geological time scale, it is useful and it has been established for a correlation of different rock sections in different regions. Okay, I'm stopping here and tomorrow we'll continue with the standard stratigraphic units.